Hello class, we are Group 5. My name is Ana Gutierrez and the lesson for today is section 3.4, Connecting Data and Probability Distributions. In this video, we will break down the differences between discrete distribution and continuous distribution. And to check for understanding, we will give you a small activity. Later on the video, my team members will solve some discrete distribution and continuous distribution problems with a surprise topic. Before we start our lesson, let's talk about tacos. Do you like tacos? Thumbs up this video if you like tacos. I'm sure most of you like tacos, and since we live next to the border, the city of Brownsville has embraced Mexican culture in their food, traditions, and people. Tacos are the favorite antojito in the valley, and just in Brownsville, there is about 60 taquerias where they have a high demand of tacos every day. Because this chapter is about statistics, to make this section easier and fun to understand, we are presenting our section topic by making a relevance with tacos and taquerias. For example, since we are talking about tacos, taquerias are the businesses that could obtain high profits. Therefore, statistics are the best option to use to obtain the possible profit by solving the expected value or mean and standard deviation. Next, my partner Monica Munoz will explain the differences between a discrete distribution and a continuous distribution.
Hello everyone, I'm Monica. Now, let's get to it. We can separate variables into two basic types, qualitative and quantitative. We can classify quantitative data even further as being discrete or continuous. Now, for continuous insight on the subject, let's walk through the differences between continuous and discrete variables. Discrete variables are countable, like the number of tacos you order at the taqueria, the speed that you eat your tacos, the number of workers at the taqueria, and the number of languages the waiter speaks at the taqueria. Continuous variables, on the other hand, can't be counted, but can be measured. Examples include the height of customers at the taqueria, the weight of a taco truck, and the time waiting in line to get tacos. Continuous variables are measured on devices like scales or timers, which may include some decimals. The weight of a taco truck could be 6,001.35 pounds, 6,010.97 pounds, or 5,098.43 pounds. By contrast, the number of tacos you eat can only be whole numbers. Now, let's look at a continuous graph. As you can see, continuous distribution creates a curved effect, reflecting the infinite number of values a continuous variable can be. With discrete distribution, only whole numbers are possible, giving us that rectangle effect on the graph. With continuous variables, we can think of probability as the total area under the curve. But for discrete variables, we're looking at the areas of separate rectangles, with each rectangle having a width of 1 and the height of each rectangle being the probability of that outcome occurring. One major difference in the way we analyze the two types of distributions is in how we calculate probabilities. For discrete distribution, we can calculate the probability of getting exactly 6 or exactly 7, but for continuous distribution, we need to find the probability of a range of numbers. In this case, the probability of any value between 6 and 7 will give us the ability to calculate any area under the curve, and that area gives us the probability of the range occurring. If we try to find the probability of an exact value like 6, it would be 0 because the area of a straight line is 0. Understand that we can use formulas, calculators, or online resources to calculate the probabilities of continuous and discrete distributions. The most important idea here is to be able to differentiate between continuous and discrete variables and their graphical distributions. Now, let's work on a matching game, where you will receive 10 quantitative topics and determine if they are discrete or continuous. Students will receive 10 cards as seen on the picture and will have to determine whether they are discrete or continuous. It is now time to look at some examples of continuous and discrete distributions. Let's go with my partner, Cynthia. And to open a new taqueria and found these stats for similar restaurants. We will use that as probabilities for our new taqueria's profit. What is the expected value and standard deviation? So before we begin, I'm just going to go over the table really quick. There's a 20% chance that we're going to have a $50,000 loss, a 30% chance that we're not going to make any profit or have any loss, 40% chance of a $50,000 profit, and a 10% chance of a $150,000 profit. Before we begin, it is important to take note of the formulas that we are going to be using. The random variable is x equals possible profit. Mu, also known as expected value, equals the summation of x times p. And our variance equals the summation of x squared times p minus mu squared. Our standard deviation equals our variance, the square root of variance. Using the table above, we are going to make another table to break down our steps. We will need to write the probability P in decimal form. So probability P, 20% would be 0.2, 30% would be 0.3, 40% is 0.4, and 10% is 0.1. So the summation of our probability is 1. Remember that the summation of probability always equals to 1, okay? We will write our earnings in place value, but just to remind us, we will denote that in thousands. So earning here, earnings in thousands is x. Negative 50 due to the $50,000 loss, 0, and 50 positive for our profit, and 150. On the same table, we are going to solve for our mean. So first, we need to find our x times p, which would be negative 50 in our calculator, negative 50. That's our x times our p, which is 0.2. Negative 10. 0 times 0.3, we already know is going to be 0. 50 for our x times 0.4 equals 20. And 150 times 0.1 equals 15. So our mean, which is our expected value, equals the summation of x times p, which equals 20 plus 15 minus 10 equals 25. Due to the formula for variance being ex squared times p, we're going to solve for ex squared times p on this side of our graph. But first we'll find ex squared times p. X squared times p. In our calculators, we will write negative 50 squared, so that's our x squared, times our p, which is 0.2. That comes out to 500. Next, it will be 0 squared times 0.3, but we know that 0 times anything is 0. So 50 squared times 0.4 equals 1,000. And 150 squared, which is our x, times 0.1, which is our p, equals 2,250. So we're looking for the summation of x squared times p, So here we're gonna put summation x squared times p equals, we gotta add all that up in our calculator. That's 2,250 plus 1,000 plus 500 equals 3,750. Okay, so we have our expected value, which is mu, equals the summation of x times p, which equals 25. Now, in order for us to solve for the standard deviation, we need to find the variance. And the formula for variance, which is up here, we have variance equals x. Variance of x equals the summation of x squared times p minus the mean squared, or mu. So just plugging it in from the information that we got on the table, we just plug it into here. We have our x squared times p, which equals 3,750, minus our mean squared, which is 25 squared. Plugging 25 squared into our calculator, we get 625, which then turns out to be 3,125. For our standard deviation, we have, standard deviation, we have the square root of our variance, which equals the square root of 3,125, which then equals, of course, after plugging it into the calculator, we get 55.9, which equals 56. Let's not forget that this information is in thousands. So for our mean or expected value, we get 25,000. And for our standard deviation, we get 56,000. Now those are our answers, and that's what our question is looking for. In this example, we did everything step by step on a graph. But if you work better with plugging in a formula into your calculator, here's how you would do it. Just by using the information that we first had with our graph, just changed up, we will have our formula for the expected value or mean to be the summation of x times p, which turns out to be negative 50 for x times our p, which is 0.2, plus 0 times 0.3 plus 50 times 0.4 plus 150 times 0.1. So let's plug that into our calculator and see what we get. Negative 50 times 0.2 plus 0 times 0.3 plus 50 times 0.4 plus 150 times 0.1 equals 25. That was what we first got in our graph. So for our variance, we would need to find the summation of x squared times p, which would be negative 50 squared times 0.2 plus 0 squared times 0.3 plus 50 squared times 0.4 plus 150 squared times 0.1. So I'm using the same information that we had in the calculator. I'm just going to square everything, or square our x at least. 0 squared times 0.3, 50 squared, and our last one is 150. It turns out to be 3,750. Now, for our formula for variance, we get the summation of x squared times p,
minus mu squared. That could easily be plugged into the calculator by 3,750 minus 25 squared. So let's do that really quick. 3,750 minus 25 squared. It turns out to be, I'm gonna write it down here, 3,125. So the standard deviation is the square root of the variance. Let's put that into our calculator. The square root of 3,125 equals 55.9, which would be 56. And then once again, we would put our final answer in thousands. So it would be 25,000 and 56,000. That's it, thank you.
A dealer's profit in units of $5,000 on a new taco truck can be looked upon as a random variable x, having the density function f of x equals 2, 1 minus x, when x is between 0 and 1 and 0 elsewhere. Find the variance of x. Our objective for this problem is to find the variance of the dealer's profit in units of $5,000. So we're going to let x be the variable that represents the dealer's profit in units of $5,000. So the formula for calculating variance of the random variable x is sigma squared equals to the expectation of x minus mu squared, x minus mu squared equals to the integral of negative infinity to infinity, and we take x minus mu squared multiplied to the PDF, which is the probability density function. But this formula can be written in an easier way. So we take expectation of x minus mu squared equals to expectation of x squared minus expectation of x, and all of this squared. So for this, first we need to find the mean of the random variable x. So it would be, we would have to find the expectation of x, which is equal to the integral of negative infinity to infinity from x times f of x dx. So we're going to take the integral of x times of f of x, which is 2 times 2, 1 minus x dx, and between 0 and 1. So from here we can take out the 2, and we have x times 1 minus x dx. So now we have to distribute the x. So we would have x minus x squared dx. And from here we would integrate, and we would have x squared over 2 minus x cubed over 3 from 0 to 1. So now we're going to replace our values. So it's going to be 1 squared over 2 minus 1 cubed over 3 minus 0 squared over 2 minus 0 cubed over 3. So this is going to give you 0, and we're going to be left with 2 times 1/2 minus 1/3. And 1/2 minus 1/3 is going to give us 1/6. So we have 2 times 1/6 equals to 2 over 6. And whenever we reduce it, it's going to be 1/3. So that is the mean for a random variable x. Now we need to find a random variable x squared. So now we have to find the mean of the random variable x squared, which is the expectation of x squared is equal to the integral from -infinity to infinity, x squared times f of x dx. So we have x squared times 2 times 1 minus x dx going from 0 to 1. We take out the 2, 0 to 1, x squared times 1 minus x dx. Now we have to distribute the x squared, and we get x squared minus x cubed dx. So from here we can integrate, and x squared will give us x cubed over 3 minus x squared over 4, going from 0 to 1. Now we have to replace our values. It's going to be 1 cubed over 3 minus 1/4 over 4 minus 0 cubed over 3 minus 0/4 over 4. And we get 2 times 1/3 minus 1/4. And this will give us 0. And we're left with 2 times 1/3 over 1/4 gives us 1/2. I know 1 over 12. And then this is going to equal to 2 over 12. And if we simplify, we get 1 over 6. So now we would substitute the values we got into the formula. So we have the variance of x is equal to the expectation of x squared minus the expectation of x, and all of this is going to be squared. So we have the expectation of x squared was 1/3, no, 1 over 6, and minus our expectation of x, which was 1/3 squared. So we would have 1 over 6, and 1/3 squared is 1 over 9. So this is going to give us 1 over 18. So this is the variance of x. So in terms of the actual profit, the variance x is going to be, or by the property of variance, we have b times a x equals a squared variance of x. So we would replace our values, and a is our actual profit in units, which is equal to $5,000. So we have b times 5,000 x equals to 5,000 squared times our variance of x, which was 118. 5,000 squared is going to give us 25 million. Times 118, 1 over 18. So the variance of the Dieter's profit in the units of 5,000 is going to be 1,388,889.